In this video, I'm going to show you a little bit about HTTP connections in Golang. So instead of showing you just the code and what I've prepared, in this video, I will show you how I really came to build this Golang program. So I didn't prepare any code. I will just show you how I build a program and how I find all the code and examples on the internet to build an HTTP server, an HTTP client. So what you see on my screen is the hypertext transfer protocol. This is the RFC of HTTP. So this explains how you make HTTP requests. So once you want to build something on a protocol, it's always interesting to have a look at the RFCs if there exists one for it. So this one is already very old. This document is copyrighted 1999. Explains HTTP 1.1. So I haven't had a look at it previously, but somewhere in this document, we should see how we can actually make a request. So here I see requests, and then I can use a method. So I know that using the method get, I can make an HTTP request. So this is what my client will have to do. It will have to make a get HTTP request to retrieve whatever information. There's no examples here. I've used this before, so I have an idea of how it should look like. Most of the time I would then go to another document, another example to see if I need something more or whether there are better examples of how to make HTTP requests. Now first, what I will show you is to use the Golang library to build an application that uses HTTP and then a client. And then I will show you how you can do it without the libraries, just as an educational purpose to see how it works under the hood. So let's get started. Visual Studio Code. I'm gonna open a new project. I'm gonna make a new folder, HTTP server demo. Open. I will need a Go mod file. So I need a new file. Go.mod. And I just need a new terminal first. Go mod init. HTTP server demo. Well, shouldn't have created it actually then. Go mod init. Creates my Go mod file. I'm currently on Go version 1.21. I need a main file. Main.go package main. Package main. And I need a main function. Let's see if we can just print something. Go run. Go run, and that should output test. And here we have test. So how do we run an HTTP server? Go HTTP server, HTTP package, client and server. Here's a server. And this actually changed in Go 1.22. So I hope I will not get into issues because I'm running 1.21. Because they updated this HTTP package to have more functionality. So let's try this code. HTTP server runs on port 8080. I need a handler. This is my handler. And actually, if you want more control over it, this will actually already do. See, listen and serve is the important part. HP handle function, and we have an HP handle on foo and a handle func on bar. So this foo handle I'm going to remove. I'm going to save, and then it's going to check the dependencies, what dependencies need to be loaded. What is this going to do? Hello queue on the path. Hello queue is going to show me HTML escaped this URL path. So go run, asks me to allow incoming network connections, and then I could try to test out with a client. So I'm just going to use telnet, localhost. So telnet often comes pre-installed, localhost 8080, localhost 8080, like this. And then I can do my GET request like the RFC describes with GET. And then let's have a look if it explains a bit better. So at some point, GET requests, request line method. Request line begins with a method token, followed by request URI and the protocol version. Right. So request URI is the path. Protocol version is going to be HP 1.1. This is the protocol version. So let's try that out. Get the URI slash or slash bar, and then the protocol version, and then ending with the CRLF. Elements are separated by SP characters. No CR or LF is allowed except in the final CRLF sequence. CR/LF sequence. Carriage return and line feed. Special characters sequences in the HP protocol to denote the end of a line and to start a new one. So what means is in practice, if I press return, I can then add another command, or if I press return again, then it will send the request. So HP 1.1 bad request, missing required host header. So for HP 1.1, I have to send a host header. So once you start debugging these sockets, like these network connection sockets, you will see that error messages really give you some good information. What is the host header? I need a header. This must be explained somewhere. Message headers. HP header fields, which include general header, request header, response header, entity header. Let's look for host. So here's an example actually. We are at the request URI 512. Get, this is the URI, the protocol, and the host header. So let's try it out. Get bar HP 1.1 host localhost 8080, or just localhost. Not sure if you have to add 8080. Okay, that works. It says hello bar. It even leaves the connection open because it's HP 1.1. If you would use HP 1.0, it will not leave the connection open by default. So if I do get bar HP 1.0, not sure if this is supported, but it is. And it says HP 1.0 okay, and it says hello bar, and and then the connection is closed. But if I use HP 1.1, it says 200 okay, and it says hello bar. So this makes sense. Let's create a new window. Open a new project, HP client demo, open. Let's open a new terminal, go mod HP client demo, go mod init. Touch another may not go. Let's copy paste this, but instead of creating a server, we are going to make connection. Back to our HP library. This time we need a client. What is the easiest way? I think this is the easiest way. Response error equals HP get. We're going to do an HP get request, localhost 8080, bar. If there's an error, OS exit 1, log fatal. Actually, I don't need to read exit 1 if you do log fatal, because fatal is the equivalent of a printf followed by a call to OS exit 1. So we can use it like this. HP get failure, and then we can print out the error if you want. Defer the closing of the body. So once we are at the end of the function, it will call the response body close, and then we can read what is in our body using IO read all. Body, and then again, we need to handle our errors as well. Read all failure. Go run main.go or go run dot. Body is hello bar. So this is how we make a simple HTTP connection to our server using the HTTP protocol. But this is a bit rather easy to use the HTTP library. It's just an abstraction. So let's have a look, if you want to make the connection manually, how that would look like. Just to get a better understanding. I already showed it to you using Telnet, but how would we use that using Go? So here we have the main function, and then we need a different kind of library, a more lower level library, Golang HTTP connections, Golang network connections, the net package. See, so we can just use net dial, and net is just a much more lower level library to make these TCP/IP connections. For example, you can also do UDP, domain name resolution, Unix domain sockets, but we are going to use it for TCP/IP. So this, because it's much lower level, now we actually have to really enter the command that we need. So you see here, it actually has this get already as an example. So we're first gonna make the connection, localhost 8080. Gonna handle the errors again. Fatal F when you have a connection failure. And then now it's not going to parse everything for us. So here we had, for example, response body. And we also have response status, which is our status code 200 OK, because this library parses everything for us. But now we actually just making an HTTP connection using this net dial, which doesn't know anything about HTTP. It just makes a TCP/IP connection. So we will then see that the first line is actually this return line. HP 1.0 200 OK or HP 1.1 400 bad request or 200. So we need to parse this ourselves now. This is always going to be the first line. Protocol number, status code, status explanation, and then we have the headers, and then here we also have the headers and then the content. So now we actually have to manually parse it. I'm not going to parse everything. I'm just going to have a look here. We're going to read one string. Let's use our buffer. Buffer is our new reader, and then indeed status is going to be the first string, and then let's just print that to start with. So I'm going to print the status. If there's an error, we need to capture it. Read string error. Let's try this. And then we probably also have to close the connection close, which gives us an error. This should work. Should close error. Go run. Okay, status HP 200. Okay. Let's say that we try something else. Path that doesn't exist. 404 not found. Okay, so that works. Right. But we only parsed one line. We don't really know what the content is. So if you want to know what the content is, we actually have to continue parsing this manually. And you see that this is just for educational purposes, because you're not gonna run such code in production where you have existing HTTP libraries to parse your data, and then you're not going to use this net library. You're just going to use the HTTP package. But it can be quite interesting indeed to understand yourself how this actually works, what is going on under the hood, what is actually the data that we get when we make an HTTP connection. And then we can say something like reads until the first occurrence. So at some point it's gonna give us end of file, so we can actually read until end of file. For something like for let's just do this quick and dirty. Or now I wish I had an AI assistant for these simple things, which I don't really use, but you can just Google it. So read until read until end of file. Here's an example, so that we have an idea how it works. Is this the same library that they are using? I'm using buff.io reader, buff.io reader. So for line, read line, oh, there's a read line actually. If there's no error, then we are going to if there's no error, we're gonna append this new line. If error is end of file, we're gonna break. Okay. So the error itself is going to be IO off. Okay, let's try. So 4. I already started that, so that was already correct. Line equals this read string. Have an error. If error is not equal to nil, then if error is equal to IO off, then we're going to break. And otherwise, we are going to read string error. I'm going to show an error. And otherwise, we're just going to print it. Fine. So this should give us all the lines, hopefully. Status, and then the date, content type, an empty line, and then a read string error. Use of closed network connection. And that is actually because our for loop needs to be here, and only then we can close our connection. That's why I use a defer. Okay, so this looks better. But we still have a print here. We're still missing one line. So let's output our line just here. It's not a pointer, so we cannot get a null pointer exception. And then if we get an error, then we will just still print a line, output the error if there's an error. And if we are end of file, we'll just do the break, but at least we printed our last line. Okay, so that actually works. So now we have our status and then the actual content, which we could now parse if we wanted to parse this. For example, if you would get JSON, we could parse JSON. If there was something in the headers, we could parse that. So now we are still using HP 1.0 because that's easier to work with. But if you would use 1.0 on some other servers on the internet, that might not work anymore. So then you need 1.1. I don't know what exactly would happen if you would use that. Let's try it out. Oh yeah, we need the host header. So we would need to add something here. Host, localhost. Let's try that. Okay, that works. 200, okay. But our connection now stays open because that's how HP 1.1 works. It keeps our connection open. So we would have to do some more logic in here. Probably we cannot wait until we have this \n. We would need to parse the content length, which is 13, and then now read 13 bytes of text to be able to know what our content is. And then it keeps the connection open, so we could do another HTTP request, because that's the optimization between HTTP 1.0 and 1.1. With 1.1, the connection can actually stay open, and then you can do multiple requests in one TCP/IP connection, which is more efficient. I'm not going to make that change. So let's just have one that works. And let's now work a little bit on our server. So this is, again, super easy to do, but how does that actually work? How do we create a socket to wait for incoming connections? Back to our net package. We have a client, but we should also have a server somewhere. I'm not sure if it's in the same package. Yes, it should be. Listen function creates servers. And here, well, we already have an interesting thing to mention. We use a Go keyword, which means this will be an asynchronous Go routine to handle the connection, which makes sense because you want to be able to accept more connections. You don't want to just be able to handle one connection and block the server, because then you will not be able to accept the second connection. You want to accept the first connection, put it in a separate Go routine asynchronously, and then if it has another connection, then we just put in another Go routine, and that way we can handle multiple connections. So we have net listen, port 8080. We're going to accept our connection, and we just need to write this function, handle connection. So func handle connection, and then we pass this net connection, and then we're just going to say we are here. We need to still handle the errors. Log fatal F, listen error. For example, if the port is in use, then we'll get an error here, and then accept error. That should work. We are here. Let's try to read something. Connection remote address. Client is remote address. Go run. Allow. Now let's try to make connection. Go run may not go. Nothing happens because we didn't get anything back. But we are here. Client is, and this is my local IP address on this port that we are getting the connection from the client. Let's stop this. Let's return something. So we actually should parse this line, otherwise we are kind of breaking the protocol. Let's just try to first give something back. So this is the first line that we should give back. How do we write something to the client? fprintf accepts a writer. No, that's not how we do it. I thought we would do it like that, but is con maybe writer? No, we'll just do con write, I guess. Con write, and then we can write some bytes. It can be an error, and then we probably get back the bytes that we have written. Let's try to write this first, but this needs to be in byte form. So to transform this into a byte, this should work. I'm not gonna check how many bytes we have written. I'm just gonna check on the error. Write error. Here we're gonna say client's connected. And then we're gonna write this. We should maybe write more things. What are we expecting? This, and then we are outputting all the other data. Okay, so we are expecting this, and then let's just try to put some dummy data just to see if it works. Content type is text plain. If it would be JSON, it would return, it would be here, application JSON, for example. And then here's going to be two returns, right? And then hello bar. Hello bar, escape the quotes. That should be it. So that's what we are going to return. So now we have a server that whatever connection we make, we say it's 200 okay. We don't really parse what we are getting, but this is just an example. You could start parsing it. We can allow that we can make this server on 8080. Go run main.go. And then we are not closing the connection. That's why this stays open. So maybe we should close the connection. If there's no error, we do connection close. Like this. Go run. Allow. Go run. Now we have everything. But we still get an error. Connection reset by peer. So now let's read the data from the client. And netcon has a read interface compatible read function here. So we can use this read to read data from the connection. Golang IO read example. So the IO reader to read from a file or a socket. We make a buffer and then we read from that buffer. Let's make a buffer. Before we are sending our data. And then let's try to read. Into our buffer. Net socket read from client. Example Golang. Just try to read some data. Let's see, buff equals make. We make a byte of a size 1024, and then we're going to read into the buffer the data, and then buffer is buff. Let's start a server. Client is connected. Our buffer has now the first line and response hello bar. Let's now try to run the client. And then now you see that the error is actually gone. We have client is connected. We get buffer, get bar, localhost, and then we respond with hello bar. And this is our write that we sent right here. So to recap, this was our first function. We would just say, if you hit /bar, then we're going to send hello, and we use listen and serve from this HTTP package, and then we build a client to connect to it. Then we said, let's make another main function, but use net listen, which just opens a socket on port 8080. We're going to accept a client or multiple clients. We're going to start this Go routine that's going to handle connection. We say client is connected, create a buffer, 1024 bytes, read the buffer into buffer. If there's an error, we print the error. Otherwise, we say this is the buffer. So this is actually, we would need to improve this code to properly read from the client. This code actually works just for our example, but it's not gonna work if the client is sending a lot of information, because you could only get the first bytes, first 1024 bytes. So something that you would probably have to do is, as long as the buffer, the end of the buffer, right, buffer, if you convert it to a string, so you first convert it to a string buff. If this buffer ends with a return, an empty string and a return, right? Because here I got a response immediately after I pressed enter, because then that's when that sends the data. But we would have to check if there's an extra empty line, then a return, and then we have the input data. So now we just immediately stopped after the first input that was sent to us, but we would have to actually check if the last part of our buffer is just empty line and a backslash, and only then we would actually parse the buffer, see what is requested, and if we have the information, we would send it 200 OK. If it would be a path that we parse that is not slash bar, we could return a 404 instead of 200. So this is very simple. This just read some data, send some data. But to make a real HTTP server, there's a lot more code that you would have to write. But this is good to show you as an example of how this actually works under the hood. So we print our buffer, and then we send our data, and then we close the connection. So that's the steps that you would have to take. And then here in our net dial, we make the connection, we ask for something, we send this data, this is what we need, and then we read the status, first read the status, and then read the other contents, print the screen. And here again, we could also optimize this code. So this is a super simple example that actually works. I hope I give you now some better understanding of how these TCP connections work, how this library actually works. This in a real world situation, you would just use the library, but it's always good to know what is behind it. What is the communication between the client and the server that needs to happen, the sequences, to really fully understand what is actually happening to make a simple HTTP request. And this is just on a TCP/IP basis, making a connection between the client and server, because we didn't even touch on DNS, for example, before we can actually make the connection. Right here, we connect to localhost. There's still some DNS resolving that happens in this netdial package, because we can pass a network string and an address, and this address will actually be resolved for us. So there's still something happening here. There's still some DNS happening here that we don't see before we actually are making the connection. So I hope this was useful for you. I hope this was useful for you. Let me know if you would like me to do a demo on something else that interests you in Golang. I'm taking requests. So if you put something in the comments, I can do a lecture on that. I can do a demo on something that you find interesting.